Welcome to the tinyML series, and we are about to start. It's 8:01 in California Pacific time. Again, welcome to the August edition of the tinyML Trailblazers series. This is the place where you're going to meet people who are pioneers in the tinyML field, people who are developing and driving this field forward, people who have tons of experience, and today they're going to share their experience with this audience. And we have a very special guest today. It's a Professor Vijay Janapa Reddi from Harvard University. So we know Vijay for many years since we started working on tinyML. And he has a very unique experience. So he's very well known in the academic world, obviously for his pioneering research for this field. But he's also very closely tied to the industry work, to the real world. And he's been driving a lot of very important initiative in this field, starting from ML Perf and then ML Commons, and now moving into the data AI. And the most significant, or one of the most significant accomplishment Vijay has done recently is his very well-known tinyML EDX class, which has like a huge traction in the world, with more than 70,000 people attending this class over the past year or so. It's a massively successful and definitely super important and super useful for the tinyML ecosystem to have this talented and educated workforce develop as a result of this. So today Vijay is going to share his experience, his background, and more importantly his vision of the future and the opportunities in this space. And the idea of the whole series is really to inspire, educate, and illuminate. So before we start, it is my pleasure to acknowledge tinyML strategic partners. So this is a long list, and there are more and more companies joining. As of today, it's Analog Devices, and also Maxim integrated as part of it, AUN Devices, ARM, DeepLight, HMPulse. By the way, our today's guest is a scientific advisor at HMPulse. EMSA, Visual Sense, PhotoHub, Greenwaves Technologies, Gravity Inc., IBM, joined just recently, HOTG, Imagimob, ITMIS, Clickertech, Latent AI, Microsoft also joined about a month ago, Nota AI, NXP, OctaML, Prophecy, Kixo, Qualcomm, Reality AI, that was just acquired recently by Renaissance, Rixon, Renaissance, SAP, Seed, SensiML, Silicon Labs, Sony, ST Microelectronics, StreamAnalyze, Synaptics, SynSense, Syntient, and TDK, and there are more companies joining in the next few weeks. There are a couple of interesting announcements. In addition to the Trailblazers series, as you may know, there are many other events happening, and this fall is going to be very interesting and very busy for the tinyML community. In about 3 weeks, we are going to have tinyML on-device learning forum. It is chaired by Dr. Daniel Pao from ST, and it's a 2-day live event, also starting at 8 a.m. Pacific time. Basically, it's going to be live for the whole world. And this event will provide an overview of the state of the art on-device learning for edge devices to make them smarter and more efficient. So the program is on the website. You can go there and check. And there is a QR code there. It will take you to the program and to the website of this event, and you can register there. And as all tinyML virtual event, this event is free thanks to the sponsors and strategic partners. So next one will be coming in about a month after the on-device learning workshop on September 27th. This one will review tinyML neuromorphic engineering. It is chaired by Professor Charlotte Frankel from Tech University of Delft. And it's a very interesting, fascinating field of brain-inspired computing. Again, the program is on the website. Very, very interesting program of top experts in the field there. So I encourage you to check it out and register if you're interested. The QR code is there. And then we are super excited about the upcoming tinyML Europe, Middle East, and Africa Innovation Forum. It will take place in October 10 to 12. It will be an in-person event. The location is Cyprus, which is kind of in the middle of Europe, Middle East, and Africa. This will be our first in-person event in this region. So registration was open this week. So you can go there and check the program and register. I would recommend to do it before September 15th. You get a better rate there for the hotel and for the conference. The chair of this event is Professor Francesca Conti from University of Bologna. And again, go and check out the program and of the event, and we have two distinguished keynote speakers. It's Massimo Banzi, he is the CTO of Arduino, and also Professor Alberto Sangiovanni Vinciletti. He is super well known in the community. Currently he is with UC Berkeley, and he is known as a co-founder of Cadence and Synopsys. So he's going to share his perspective. So very interesting event. It's going to be very diverse technically, and plenty of opportunities for networking there. Real quick, so the tinyML communities are growing, over 10,000 people on LinkedIn and Meetups. The links are there, so if you're not members there, go and join, and you will see a lot of information there related to tinyML. And likewise, there's a YouTube channel. You can subscribe to this channel now. It has a lot of information, tons of videos there. And today's video will also be uploaded there this week. So you don't need to take notes. The video will be there. At this point, it is my pleasure and it is an honor to introduce the host of Trailblazers series. We are very fortunate to have Dr. Chris Rowen being a wonderful host here. And Chris is very well known in the community for his accomplishments and for his leadership, thought leadership and company leadership for many, many years. He started tinySilicon many years ago, and he's been very active in the architecture space, in the IP space. And in the past many years, Chris is very passionate about Edge AI, tinyML. He co-founded a company, Bubble Labs, that was acquired by Cisco, and that's where Chris is currently working as a vice president, and he is in charge of machine learning and AI there in the WebEx area. And Chris is recognized by the community. He was named an IEEE fellow in 2015. And coincidentally, Chris has a master's and bachelor degree from Harvard. That's where our speaker's guest is today. So, Chris, the floor is yours.
Well, thank you very much. It's a great pleasure to have a chance to sit down and chat with Vijay Janapa Reddi. He's Associate Professor of Engineering and Applied Sciences at Harvard and has been widely involved in developing and proliferating the ideas of tinyML, particularly through his edX online course, which has been taken by more than 70,000 students. You know, this is one of the single most important vehicles by which people are coming up the learning curve on the core techniques, concepts, and applications. He's also a founder of the ML Commons, which is really driving acceleration of AI innovation and has really been able to have a big cone of influence on the ML community with his development and research work with ML Commons and with the edX course on tinyML. So welcome, Vijay.
Thank you, Chris. Great being here. Appreciate the opportunity to chat with you.
Oh, good. So maybe a good place to start is by looking especially at, or starting from, well, how did you get involved? How did you get interested in ML, in tinyML? How did you kind of chart your path to where you are today?
Yeah, that's interesting. So it actually kind of started when I did my sabbatical at Google. And I was actually in the Pixel SoC team, the one where Google built their first Tensor Core for the Pixel smartphones that they're building. Mm-hmm. And one of the things that I was doing when I was there as an academic, and at Google, you get a lot of freedom to kind of explore what you want to do. They let you kind of run wild and cause a lot of trouble, which is kind of what I was up to there. And one of the things that I noticed was that, we were trying to build these accelerators and this custom SoC. And often I realized that teams were kind of struggling with building their ML accelerator because everybody would want to want more SRAM, want more performance, and want more power and so forth to build their accelerator. But then I felt that, wow, there's got to be a benchmark to understand, like more systematically, if we're building this costly chip, there's got to be a way to understand how we make these trade-offs. That led me down the path of thinking about, wow, we need an inference benchmark, a machine learning benchmark. That's really where it kind of started, where I was like trying to put together a set of machine learning tasks and trying to dig deep into the ML components to see how can we get consensus from a variety of different people to agree on what the benchmarks need to be. And then, of course, once you touch that, you start digging really deep into the mechanics of just ML, and you start realizing just how complicated the system stack really is, that it's not something that we have done before in reality. And so that's kind of where it all began.
Yeah. So, one question that naturally brings up as you get into benchmarking and you get into this very polarizing climate of, mine is better than yours. And people try to make it simple by adopting principles, but that inevitably leads to a certain number of fallacies. So what kind of fallacies do you find yourself wrestling with in this world of ML performance?
Yeah, that's a really good question. I like to say that the benchmarks are good and benchmarks are bad. There's a time when we have to focus on benchmarks in order to make sure that we all speak the same language, when there's a lot of confusion around the space. That creating a standard benchmark kind of allows us to kind of bring the community together to focus on a core set of principles that we agree on. Mm-hmm. And the natural tendency, as you kind of focus on that, is to over-focus on the benchmark and start doing quote-unquote benchmark engineering, which is a big concern, obviously, as you would well know. And I think at that point, once you start streamlining things, it becomes very easy to kind of get stuck in the rut. Well, you don't want to change things too much because people get comfortable with that benchmark, and they have invested a lot of money in building that benchmark and optimizing for that benchmark, and they don't want any innovation in that benchmark. And if the benchmark is too innovative, then they push back and say, no, that's not going to look good. But then then you get into this problem where it's like, well, we created the benchmark to accelerate the industry. Now we've got this benchmark, which is actually slowing down the industry. So there are like ups and downs. And I think that's like the big thing that I really try and keep a lookout for. And one of the nice things, at least in the way, quote unquote, this ML Commons organization has been structured, is we have, yes, the industry kind of commits on the core ML Commons, but there's an ML Commons research group where we actually push quite aggressively into new areas, and we try and bring in new types of benchmarks, new kind of creative areas. So I think it's extremely important to be very wary, right? There's no one thing that's good forever.
Right. So what are some of the new areas that you think are critically important, either from the standpoint of benchmarking or perhaps more broadly in terms of developing new applications or techniques around edge machine learning?
Yeah, it's really interesting. Just before I hopped on this call, I sent out a mail talking about wanting to build neuromorphic benchmarks. And so it was kind of interesting that Evgeny was talking about one of these events that's going to happen, which is around neuromorphic computing. And so one of the things that I've been thinking about is like, okay, we want to accelerate the neuromorphic space, but if you kind of look in that space, there are no real standard benchmarks and no standard good baselines that we all agree upon. And I think like that's one area that's really sort of interesting from a processor sort of a standpoint or design sort of standpoint. And again, for people on the call, like, one of the reasons we want benchmarks is because if you can systematically measure performance, then you can make generational comparisons about, are we really making forward progress? And that's why I think benchmarks are important. So neuromorphic is one of the first thing that kind of comes to mind because it's at the top of my.
Yeah, but let's pick on that a little bit. What are some of the other major themes that you see as being particularly important going forward? Things that we in the wider community of people working on both base technology and applications should be tracking. Yeah,
the big thing is undoubtedly data, right? I think everybody agrees that it's, ML, data is the new code. And so if we don't really understand data quality, and if we can't measure data, the data sets that we have, if we can't really put numbers on them to quantitatively compare quote unquote data set A versus data set B, I think that's going to get us into a lot of problems as we go further down the road. I think we have a very good grip in the ML space around how to engineer models, how to build a low-level system stack, be it software or hardware. But this is all assuming the fact that the data is somewhat static. When in reality, we know that the data is like the internet. It's constantly changing. It's constantly evolving. And data is effectively the code that's actually triggering much of the execution. And so I think like over the next 5 years or so, I think there's a lot of awareness that's slowly starting to cook now around systematically understanding how we build better data engineering pipelines that allow us to kind of, create data sets extremely fast. There's also a need for actually measuring data quality. It's interesting, like, can we put a number on what's the quality of ImageNet? What does that even mean? Like, these are some basic questions I think we all got to sit down and seriously ask ourselves, because this is something that affects everybody. It doesn't matter if it's a data center related task or if it's a tinyML related task, it spans the entire ecosystem. So I would say data, if there's one thing I'd place my bets on.
Yeah. And data brings up, lots and lots of questions, because there's, both the question of kind of in the abstract, how good is this data? But then there's the question, well, how well does the data set that I can get access to reflect the data that my application really is going to be processing? And at the same time, there are real questions of social responsibility around data, because you don't necessarily want to, codify even who your typical user is, if that means you're implicitly excluding the potential users who, maybe because they're not the usual gender or ethnic background are maybe, affected by it. So, when does data open doors and when does it close doors, I think are really important questions for us. How have you wrestled with kind of these two questions of how do I get data that fits my actual use case, and how do I get data that represents a responsible approach to diversity?
Yeah, so the way I've been thinking about data is really, I would like us all to kind of shift our mindset away from this notion of a data set, because I think that's really where we're getting into the fundamental problem that you're raising, which is if I quote unquote create a data set, the data set inherently has certain properties associated with it. And the question where you're asking, well, does that data set really meet my needs? And that's kind of challenging, right? Let's say, to be more specific, we could say we want a data set for a security camera. Okay, well, that makes sense. But then obviously it depends on what the use case is. Like, are you talking about a security camera that you specifically want, very active at nighttime where the images are very different, or just a security camera in broad daylight? Those are two totally different things, right? even though the functionality is exactly the same. And I think the way to think about it, and that's where we get in the problem, because we don't think about the use case and we try to create these monolithic kind of data sets and say, oh, this is a data set. But in reality, I think that's a wrong perception or the wrong mindset. I think what we got to really think about is that the data set needs to be curated on the fly. So in like 3 years, maybe in 5 years, what I would envision is that we would have data engineering pipelines where you express some sort of intent about what you're trying to capture, and then we have data pipelines that we have that will actually synthesize curate a custom data set for you, which you then use to train the model, blah blah blah. So we're going to have large corpuses. In my head, there's a decomposition. So one is we want very large, messy data sets, quote unquote. Think of it like the internet. A good example I often like to use is think of how, quote unquote, a Google search engine, for instance, works. They don't go out and cherry pick the best websites and say, oh, this is the perfectly designed, it's got all the metadata and so forth. No, you just go out and you suck in all the data you can from the planet, and you do this continuously. And that's one portion of the puzzle. The second portion of the puzzle, the front end, are these ranking algorithms that you come up with, right? And so when we put in a query request into the website, right, what you type in is your intent about the data set. So in effect, they have to generate that data, quote unquote, data set for us on the fly. We then use that data set to find what we want to do or do what we want to do, right? So they don't try and create this perfect data set that works for every single person on this planet. So I think like that's the way we got to start thinking about machine learning related tasks. It's like, okay, let's go ahead and build data engineering pipelines that can ingest data from all over the place, multimodal data, audio data, text data, whatever. And then let's build front-end interfaces where you can actually query this large messy, noisy data, and then you query it, and then it creates a version of a data set, and then you use that version to then go and do whatever you want to do. I think like we need a systematic way of systematically change our approach to how we think about data to be able to kind of really solve the problem, so that everybody, quote unquote, gets the right data set that they want with the properties and characteristics that it needs to have.
Yeah. There's a central irony in what you say, because if you look back over the last 6 or 8 years, one of the big ahas of machine learning has been, oh, I'm not going to write an explicit algorithm. My function is implied by the data that I use to train a network. So I've kind of moved from, programming by algorithm to programming by data. And now effectively we're saying, well, but it isn't the data. It's sort of the algorithm that I use to collect and generate and label and select the data. So we've kind of gone from algorithm to data back to algorithm in a sense, but now have circled up to this level at which it's the algorithm used to create or select the data that becomes the core of specifying the answer that I want to get.
Yeah,
is that a good way of looking at it, or do you see it differently?
No, that's a really interesting way that you just kind of put that, because I never quite thought about the fact that we've come back again to, oh no, you still need to actually you need algorithms that can actually understand how to find the right data. And that's something we have to kind of, well, there's no guarantee to say that in itself is not going to be a neural network or some sort of ML-based method, right? It could very well be that, or it could be, a rule-based method. But yes, but I think that kind of brings us back to kind of realizing that it's not all about just data, right? In a way, getting to that data might need us to still appreciate what we have done historically in CS.
Right. So I want to pull a little bit on the thread of how your course developed, how you decided to do it, how you went about building a successful mock. How did you really get to the level of popularity, and what were the key choices you had to make? Because a course can't be all things to all people. So you're explicitly saying, I am going to do this, and I'm not going to try and serve, these people or these ideas. What was the sieve that you went through in order to decide what was in that class? How did it develop?
Yeah, I think the first, before I talk about how we structured the quote unquote syllabus, I think the more important was like, why, or what led me to actually wanting to put such a course together. This is a bit, it's not technical, but it's really sort of something I'm passionate about, right? I think like one of the big things that I've found at large is that there are lots of talented people on this planet. Talent, there's no shortage of talent, if you ask me, given our population. But then the number of people that can kind of like squeeze through all the layers of mesh and filters in order to come up to, a handset of schools and so forth. There's so many factors involved, and it's not just pure talent. That's the reality. I think there's so many other things that kind of come into play that limit us from reaching, our fullest potential. And that's always kind of been in my head. And that kind of what is really led me to kind of thinking about, okay, how can I share what I am fortunate to have access to with a wide audience? And I've thought about this way before the tinyML course, actually launched. The tinyML course just happened to be the right mechanism to actually inspire people and be able to share that globally, because it's got a beautiful aspect of, hands-on component where you have these small little devices, right? Where you can that are cheap and they can actually globally, make them accessible. And another aspect is, wow, you're still at the same time teaching them something that's quite cutting edge. I think that fusion is what really kind of led to the spark in my head. I was like, this is it. This has the potential to train a new generation of students who are probably going to do something so unbelievable that you and I probably can't think of today because we're limited in the boxes that we've kind of grown into. Yeah. And that is really what inspires me about this whole thing. And that's what kind of like set me on the thread that, wow, if we can make this knowledge globally accessible, I think people are going to come up with things that are going to change the world in ways that we can't imagine. And that's kind of what really kind of, lit the whole thing on fire. Everything else was just, that's the easy part. It just takes time and engineering, quote unquote, to kind of build the material and make it available and all that stuff. But that realizing that spark was sort of the critical thing.
Wow. As you have developed benchmarks or pursued the technologies or built the course, there's always some points at which you ran into the wall and you had to pick yourself up and choose a new direction, that some problem was too technically hard or some problem was too organizationally frustrating to make progress in the direction you originally intended. Tell me about one of those setbacks and how you chose to overcome it or move around it.
Yeah, I'll go straight back to when, where, quote unquote, the whole benchmarking concept started up around ML, right? Which I was telling you was, I was doing my sabbatical in the Pixel SOC team. And one of the biggest challenges, I was surprised by this, one of the biggest challenges was that I didn't necessarily get the support that I thought I would get from the people around me when we were building, SOC architects and SOC performance, engineers and so forth. Everybody who understands performance.
Yeah.
Like everybody who understands benchmarks, but no one wanted to do it, which was unbelievably confusing to me, because I was like, if we had this, it doesn't have to be something that the whole world agrees on. If, let's say, we are within the collection of, the processor team at large, we can get some consensus. That I thought it'd be a no-brainer. And yet, that was where I completely felt like this extreme pushback. It was like, why do we want to do this? This is, it's a waste of time kind of a thing, which I didn't quite understand. And so that, so that was sort of like, but I kind of continue to push on it because I believe that I think there's something in here, and there's clearly, the way I overcame that was realizing that there were clearly a handful of people who were kind of getting that mindset, but they weren't getting the support either. So it was like we started banding together because we were like, oh, it's like, we know when this is important, we got to do it. And so then, of course, because you have that collective amount of passion, you realize, okay, well, I think we should try and shop this around and find the people who kind of connect. So that's kind of what happened, going out and meeting other people who were like, yes, this kind of makes sense and this makes sense. And these are all extremely smart people. So even though I was kind of skeptical about, well, is this the right thing to do? If there are enough smart people around that are rallying around this and spending extra time on it, that gave me the confidence that, okay, like, I think there's something in here. It's not just me being crazy.
Yeah. So let's talk some more about the future. And you've done an eloquent job of talking about kind of the future of data pipelines. But what are some of the other important trends with respect to ML as a whole, or edge ML, or ultra low power tinyML, in terms of either applications or tools or architectures that you think are going to be the things to watch? What's your watch list, or where do you think that you can, push on things? What should we be doing, or what should you be doing?
It goes back to data, but not in the same sense of measuring data quality. But I think there's real dearth of data sets for the wide distribution, a wide population out there. So let's say, for example, we talk about just speech, for instance, right? One of the things that I'm extremely passionate about, and I think a lot of us should be excited about, is that long tail. Like, for example, there's 7,000 different languages spoken on this planet, right? And despite that, there are only a handful of languages for which we actually have models. Like, even if you look at state-of-the-art systems like Google, Alexa, Siri, and so forth, they literally support only a handful of languages. And there's a good reason as to why that is the case. But I think, like, it raises this question about equity in the ecosystem at large. And we need to find a way to incentivize that long tail of languages where you typically don't get, a lot of interest, because one could argue that the big tech might not see much value in it. But that's also a place where I feel like there's a lot of potential for startups and incubators and local areas to kind of explore new things. And I think if we can empower people regionally in developing countries and so forth, like, help them understand the basic nuts and bolts and build the right tools so that they're not becoming ML experts, but rather they're understanding how they can, for instance, build a small tinyML model that kind of works for specific keywords, in their region, in their, native tongue. Like, that's an area that I find to be remarkably easy to actually really bring about a bit of equity in the ecosystem. Like, that's one I could say that we should all be doing. This might not, I really believe that has the potential both to educate people, to bring about new technology to the ecosystem, which then results in potentially generating startups and, leading to people improving their lives at large. That's the kind of stuff that I'm really passionate about. Pushing state of the art and so forth, I think that's a whole different topic. Like, so there are two major threads in my head. But it's the one that we often don't talk about, that I feel like we need to talk about a lot, is bringing, widening access to this machine learning technology without having them become ML experts.
Right. But it also gets at, as you mentioned, there is this fundamental deficit when it comes to pushing technologies that don't have, a global economic impact. Because, I know this from even my work at Cisco, that, we're moving our WebEx virtual assistant onto more and more languages, but it's a long tail. And if we actually look at the commercial impact of the N+1 language, you go, I'm not sure this makes any sense for us as a global corporation to add, that next. It's not an obscure language. I mean, they're even fairly mainstream languages, but but they're just not that many users compared to things that aren't language dependent. So language is a barrier of a sort. It's an economic barrier, almost more than a technical barrier.
Yeah, exactly. And I understand that from a company sort of standpoint. I understand if I was responsible for this, I'd probably do the same thing, because the numbers have to work out, right? Just to kind of keep the whole thing going. But at the same time, the biggest fear that I have is that this, if we were worried about the digital divide in the previous decade or 2 decades, I really feel like the whole AI concept is just going to make things so much worse, because because it's so easy to get wrapped up in just kind of, this, obviously the space moves extremely fast. That's one thing. And two is that it's so easy to get left behind in this space. And the biggest concern I have is like, what are the ramifications of doing that?
Yeah, right. Well, certainly one of the things I found is that phenomenon of kind of the localization is not an issue across all the tinyML. Babel Labs got its start in noise removal. And, we did the obvious thing. We trained it primarily in English. And then rather sheepishly, one of our first deliveries was to a Chinese company. And we said, we don't know exactly how this is going to work for you because it was all trained in English. And, Mandarin is pretty different. And we were just stunned when they came back and said, we actually think it works better in Mandarin than it does in English. And so one of the unexpected benefits was the way we trained it really got at the essence of human physiology. What is vocal production, not about what is the language. And so it turned out to be, despite our efforts, to be actually quite universal. Video to a fair extent is also pretty universal once you get past, some difference, some cultural differences and some trivial differences in, skin tones and hair color and things like that. But it isn't hard in many of these areas to build things that are remarkably universal. Mm-hmm. But language is the great divider.
Yeah.
I don't know of any other kind of fundamental characteristic of human behavior which is so distinct when it comes to natural language understanding. So I'm hoping that that's an outlier of a problem and that we can build things that are fundamentally very inclusive in these other dimensions. But it's such a critical one because when natural language processing works well, it works so magically well.
Yeah.
But here we're up against a really hard problem of the 7,000 languages, or even, the 100 most popular languages. How do you think we overcome that? Other than, gosh, we're going to have to create these incentives for groups with smaller and less wealthy populations to get their own natural language technologies.
Yeah, this goes back to that second half of that question we were asking about. It's around social responsibility, right? Like,
yeah,
for better or worse, it kind of falls into that bucket where you can't really put a number on it and say, okay, well, this is going to generate X amount of revenue, and so this is a great thing for your promo case, right? I think it falls into that, and I'm sure there are going to be efforts, and there are efforts around this space that are like more volunteer kind of driven. But I think that's one of the big opportunities, I feel like, for the community to kind of drive it.
Yeah.
And a very simple example would be, just kind of comes to my head, is like the whole notion of having common voice, for instance, right? Common voice where you can quote unquote donate your speech and your time, right? Efforts like that exist, and I think they need broader support. And in some ways, I would say that it would really be helpful to think about it more on a larger scale. Like, for instance, what if we could create competitions at large, right? Where we encourage people that are more regionally focused to say, hey, for example, if you're in India, I've been thinking about this, is like, can we create a competition, for instance, to build, a model that can work well in these different languages? And then, there's a prize and all that good stuff. And one of the expectations is they make the data set publicly available, and to kind of like create that ecosystem. Because I think once we kind of jumpstart it, again, there's never really a shortage of talent. And if you ask me, I think people will create market values out of that. But it's the data that's limiting them, right? So we have a responsibility to kind of help incubate that data process. And I think if we do that, the rest of the pipeline will just kind of automatically fall into place.
Yeah, that seems really important. I want to go off on another tangent. Partly this comes from having gone through Harvard, a lot of years ago, and I was associated with, engineering and applied sciences. I took a lot of my coursework there, even though I was really a physics major. But what's it like doing engineering in an institution that's best known for everything else? I'm really curious how kind of the engineering mentality has evolved within that institution. And what does it say about the relationship between engineering and the other sciences and the humanities across the global academic universe?
Yeah, so I'll tell you, like, I love doing engineering at Harvard, hands down. And the reason is because the way engineering is looked at is not so much like, oh, is this, it's not about just engineering some piece for the sake of kind of pushing that state of the art in that little black box. It's the way engineering is kind of thought about it is that it's about making interdisciplinary kind of connections, which is really, I think it's deeply nested in the culture at Harvard that there are no strong boundaries. Right? So for example, you could say, oh, there's electrical engineering, there's computer science, there's computer engineering, right? There's data science and all this stuff. But like within Harvard, there are no boundaries as such. There are no hard walls like, oh, this belongs in this department or anything like that. And the school at large does a great job, and the faculty do a great job of kind of keeping that fluidity in place. And we preserve that. And a lot of the people who come here, in reality, like that's also something just inherently when we're doing faculty interviews and candidates we're considering, we want to see, are they capable of making these interdisciplinary sort of connections? Because that's the culture. Right? And like, for example, when we're bringing in even students, I like to say, look, if you want to be pigeonholed into a certain area and that's where you feel most comfortable, I candidly tell, at least from my research lab, I say, this is going to be a horrible place for you to be at. Because I don't care about building I'm not passionate about building a processor microarchitecture or building a certain compiler or making a compiler fast. I care about solving a problem. And if that's what motivates you, then you will find the right place to build a solution. Because you often find like everything looks like a hammer if you're a domain expert in one niche area. How can a microprocessor architect build a good build a good data path if you don't really understand what kind of code is actually coming through from the compiler? Which means you actually have to appreciate compilers. And how can you build a good processor, if you don't understand operating systems and what the role of the operating system is? Like, so you kind of have to understand all these interrelated connections across fields. So you can't just be like, oh, I just want to write a better compiler. I'm like, you can write a better compiler somewhere else, but don't do it here. Right? Yeah. That's just an example. Right now, if you kind of take a step back, the same thing kind of happens when you talk about like machine learning. Okay, so we do a lot of work in machine learning systems, for example. Okay, well, how can you understand how to build good machine learning systems if you don't understand the data side of things? Because machine learning is tightly coupled with data. So backtracking to your question, the point is like, the way engineering is kind of looked at Harvard is that you really have to understand connections. And there are a few places, I think, that actually really do this. And at large, if you kind of look at educational systems, I mean, what are we trying to do? We're trying to build technology to improve lives. At the end of the day, that is what we really do.
Yeah, right. You're really ecologists rather than anatomists.
Yeah. And I think people miss that. Like, people don't understand that. I don't think, like, even when I was going to school way back in the day and so forth, I don't really think people ever try to get me to understand that that's what we're really doing. We get so caught up in the engineering mechanisms. And I think that's why I kind of really enjoy being in a place where liberal arts education and so forth is really kind of, it's sort of in the blood. And I think that leads to a very different style of an engineer. And if we have that right, then we probably wouldn't be dealing with bias-related issues and all these things in the real world because we would have actually thought about it.
Exactly.
So, yeah.
Let me pause for a moment and invite the audience to start submitting some questions. We really want to hear from you about what you want to hear from Vijay on any of the things we've talked about or anything else that you think would be important. Let's turn a little bit to neomorphic computing. I've always been fascinated by it, but at the same time, wondering sort of beyond the obvious attraction of the parallel to biological systems, what's the set of problems where it's likely to be significantly better than the current kind of mainstream digital synchronous systems we mostly build today in the ML field? Where do you see its great potential in terms of either what problems or what characteristics of solutions it's likely to get us to?
First, I'm going to say I'm not an expert in this space, quote unquote, so take what I say with the grain of salt. I have this intuitive feeling that it's great for tinyML sort of sensing kind of tasks where you're really dealing with, sensing data that's kind of coming through, and that's like that first level sort of filter. That's kind of like how I tend to generally think about it, because I think once you kind of use that as sort of a filter to kind of solve, because low power and efficiency and so forth is good, and you tend to have very specific use cases in, say, tinyML, for instance. I think that makes it easy to kind of narrow in on the scope and really try and get the neuromorphic subsystems to actually shine. And what has the data kind of filters through, I think, like once we get into like, aggregating all of this data, then I would say that it kind of distills back into more of the traditional realm that we're already used to. That's like one level of separation, I think. So as we go more and more to the endpoint, I think it makes more and more sense to look at it dealing with sensor data coming through.
Yeah. I mean, I think that's certainly one of the big organizing principles is, as you move the ML closer and closer to the sensor, you get closer and closer to this idea that, the world is not sampled. The world is not synchronous. And therefore, there are real potential advantages in, staying in this serial domain, staying in an analog domain because of energy, because of information loss, potentially, as you transition into the synchronous digital world that we all know and love because it's a great organizing principle for large scale computing. And so where you put the ML along the sequence is going to, definitely influence, where the leverage is going to be.
Yeah.
There's a question that came in. Really, it's what about ML use cases for routers and switches, for networking routers and switches? What have you looked at? What do you think is interesting? Where do you think some of the untapped potential is in network operations?
I think most of the use cases that I've heard about where people have come like asking us to do a lot of work has been really in sort of like malware related detection. That's been like one of the most common sort of requests when I've been interacting with companies, is kind of looking at it from that sort of a perspective, and understanding more global distributed behavior, many of which I actually don't work on, in fact, but I'm always surprised that I keep getting the same set of requests often, and I'm like, that's a very different beast of a problem.
Yeah, right. It's an interesting problem because often the traffic is encrypted in some way.
Yeah.
And so you shouldn't be able to look inside. And so you only can kind of look at the layer of, well, how was this this packet or stream of packets, labeled, tagged, addressed. Yeah. And you can do presumably traffic analysis kinds of things, but it gets hard to do content analysis unless unless you really are in a position to do deep packet inspection. Yeah. But you sort of hope that the world gets better encrypted over time.
Indeed.
Here's another question. What do you see as the biggest challenge to continue the momentum for tinyML globally? What are the challenges that you think that the tinyML movement may face? And what are the things that will continuously invigorate that effort?
I genuinely believe one of the biggest challenges we have for tinyML is going to be building the right infrastructure so we can, quote unquote, operationalize the whole momentum around tinyML. It's, I've said this in prior talks where I say it is in reality easy to kind of deploy models onto a single device, right? But it's a whole another thing when you actually are trying to scale this out. Like, how do we systematically think about this on like a fleet of embedded devices? And don't assume that the fleet's going to be homogeneous. How do you deal with the heterogeneity that we have in the embedded ecosystem? Like, we don't have a lot of the bells and whistles that big ML systems have, where we have rich ecosystems, like rich operating systems and, rich containerization, frameworks and so forth. We don't have a lot of that in place for the embedded ecosystem. And I think like because of that, we'll very quickly run into problems in systematically doing management of these things. We can probably deploy the model, but really building a life cycle around it, I think is going to be fairly challenging for tinyML. I think like that's one of the things. That's one. And the second one, hate to harp on this point, but I really think data is going to be the Achilles heel for all of us. Like, again, we might be able to solve a few problems, but as you mentioned earlier, Chris, right? Like, everybody's got their own little thing that they want to do. So what does this mean? Like in tinyML, you don't have very large margins and so forth. So it's not like you're going to have a massive team, a massive ML team doing a lot of the engineering work. I think so somehow we have to create data sets and so forth that are just available, like that actually work across, many different areas. of generalization, I think, is going to be a big problem. And that comes back to data.
Great. Well, we're now getting a small flood of questions coming in. What do you see as the particular ML application challenges in developing remote healthcare devices and applications?
Oh. So I'm just trying to, okay, what challenges does tinyML applications face in developing a remote healthcare device and applications? I think the one concern that kind of pops up in my head is kind of just getting approvals at large. How do you, for instance, get FDA approval on a device? Today, if you look at how FDA, for instance, if we talk about FDA approving AI methods at large, it's very ad hoc. In fact, James Zhao at Stanford did a really interesting study where they found that what FDA had approved was actually, a lot of it was wrong because they didn't follow systematic methods. What would work in, for instance, one test set scenario wouldn't actually generalize it, but FDA itself is trying to understand how to evaluate this technology before they can approve it. And I think like that's going to be a big impediment to really getting things really deployed for healthcare.
Yeah. There's a question here that you started to answer, but this questioner wants to know, what do you look for in prospective grad students? And how challenging is it to find students who are a good fit?
Yeah. Well, for good graduate students, I definitely don't look at their GPAs. Let me be very candid about that. Yes, I mean, the students are going to be good, but especially because you're talking about graduate students, it's really about what's the mindset with which people approach problems. I think that's really what I try to cut. And often, believe it or not, I like to ask students, what are you most passionate about? And you'd be surprised how many people choke on that question. You would think that after spending about 20 plus years as a human being, you'd know what you're most passionate about. And people will often come up and say, okay, well, I'm really passionate about computer engineering. I'm like, I don't know what the hell that even means. How can you be passionate about a field, quote unquote? Being, for me, passionate really is about like unlocking. I like to answer questions. I like to understand how to answer questions that don't have answers. Like something like that. That's the true underlying current, because when stuff hits the fan, that's what's going to carry you through, right? You got to have that true underlying burning passion, something that you really believe in. Like, not like I want to make a compiler go fast. I want to build technology that actually makes lives better, because you can work with that. You can find something that kind of fits that mold. So I think that's the kind of stuff that I'm really, really trying to narrow in when I'm actually interviewing graduate students. Because do they have the grit? Becomes pretty obvious when you start asking those kinds of more personal questions.
Yeah. Let me try and summarize this question from Thomas on data set benchmarks. What are the potential metrics that would be useful in data set benchmarks?
That's a great point. You should totally attend my talk at 3 o'clock at the Snorkel AI event, where I'm talking about data perf. And it's the exact thing that I want to talk about. Talking about what are the benchmarks, for instance, what are the kind of different things that we have to look at. For instance, one could simply say, I have quote unquote ImageNet, right? And it has millions of images. One of the benchmarks in there could be like a data set selection algorithm, which is, what's the smallest size of that data set that I would need in order to attain the same accuracy. So accuracy would still be the metric, for instance. But the key question is, can I have a very small training set? Because if it takes me, for instance, a month to train on ImageNet, just kind of making it up, but if I'm able to cut that data set down into half while maintaining the same sort of test set accuracy, and that's great, because now I effectively cut down my training costs from a system standpoint into half. Right. So identifying that sort of a course of selection, like a training set selection algorithm, that's a key thing. And the metric still ends up being accuracy. But there are cases where, for instance, you actually want to change, the accuracy metric itself, right? The metric itself is different. I don't want to get too much into the data perf thing, because that in itself is, a full-on talk.
Yeah, that's a whole, that sounds like a great topic for another 3 hours. We're running very short of time. I'm just going to choose one more question here. What do you think tinyML might do to improve edge cybersecurity? You think of applications or issues there?
Quote unquote cybersecurity, cybersecurity is a broad thing, so I'm going to interpret it in a very particular way. Let's take the very simple example, for instance, like, if we just want to have like a person, counter, right? What is that going to need? Well, if I want to do that with some sort of camera-based input, then I'm going to have a camera input that's kind of dumping its images, and a CNN model or something that's kind of picking up those images, and it's doing an inference to count how many faces it sees or how many people it sees. Now, that seems fairly simple. Like, one thing in there immediately around tinyML in my head would be like, well, there's a potential risk if you just kind of think of that whole pipeline, because, well, in addition to seeing that, there's a possibility, for instance, to leak the data, like leak the facial information data, right? Which it's not supposed to happen, because that raw data is kind of coming in. So, but if you kind of think about it from building a proper tinyML sensor, we should be able to architect it in a way where the ML model sees what it needs to see, but then there's a very clean delineation where it only sends out, all binary values, 0 or a 1.
Mm-hmm.
So there is no chance for the rest of the pipe to ever get access to the raw image data, right? So there's no notion of how you think about that as an opportunity, where I think if we architect the tinyML sensor systematically, then I think we can really, that affects the cybersecurity kind of a thing, right?
Yeah, right. That's an interesting perspective. In fact, I think this has been a really interesting hour, and I'm sorry that it's ended so soon.
I know.
It's been wonderful.
An hour. I'm so surprised it's been an hour.
Yeah, I'm really delighted to have had a chance to chat with you, and I thank you, and the whole audience thanks you, Vijay, for sharing this hour and this really interesting, quirky perspective that I think is really important to the future of tinyML. So thank you very much.
Thank you, Chris. Thank you, Evgeny, and everybody involved with the tinyML community. I think the tinyML Summit does an incredible job hosting these things, and I think it's a great resource. So thank you for everyone's effort.
Right. Yeah. And I hand it back to Evgeny.
Yeah, thank you, Chris, and thank you, Vijay. I cannot 200% disagree. It's been super inspirational, very educational, and illuminating. I really enjoyed it. And I have a liberty to ask my favorite last question at the end, which is of philosophical nature. And I guess I know the answer. I'm just checking how well I know you, Vijay. So you're a very successful professor at Harvard, so life cannot be better than this, and it's not enough for you. You're doing ML Perf, you're doing ML Commons, you're doing now data, you're advising companies, a lot of things on your plate. And this is where in the success stories in the Trailblazers series. What does success mean for you? What is that for you?
That's a great question. I find that success for me basically means can we move the industry forward? That's one way of kind of looking at it. Like I often like to kind of think like, is this something that helps all of us build a better ecosystem at large? That's one thing. This is a bunch of answers, right? So that's one from an impact sort of a standpoint, because that is very satisfying to know that, okay, you're doing something that is helping multiple industries come together. And that's something that is quite unique being an academic. It's very hard to do if you're part of another company to try and bring consensus around, because everybody thinks you have something in your head that you have a secret agenda. But as an academic, it gives you that neutrality. But at that same point, it kind of, there is a responsibility, I also feel. With that freedom that I have, it also is a responsibility to use that freedom to create something or bring the community together, which is specifically the industry. So that's one way I kind of look at quote-unquote success. Am I able to use my neutrality to kind of bring various companies to kind of collaboratively work together to, move the needle forward? The second thing I would say is often around education, right? Being an academic. Nothing is more satisfying for me than seeing or creating pathways for the next generation. And I think that is honestly, well, I know that is honestly why I'm an academic, right? And for me, it's when I see students, whether it's high school student getting an opportunity to do some research, and then they move into undergrad, or from an undergrad they move into something, be it a company or research they're doing, but they find their sort of a resonance, and that when you make that connection or you see that success, that is priceless. Because at the end of the day, as crazy as it seems, like if we can enable this at scale and so forth, which we're all doing with tinyML education efforts and all these kinds of things, that is very satisfying, right? Because then we're in a really, education is kind of borderless, right? We have all these borders and countries and all this stuff, and I'm often like, that's just all fake stuff. I mean, there's only one real border, people, and it's called this round blob that we're all stuck on, right? and so I think education is one of those things that like permeates through borders, and I think that's like when we see that, like we're able to share what we know outside of our institution and affect other people and give them the opportunity and the confidence that they can achieve something. Oh, that is priceless. That is another form of success, because it's the next generation that's going to make the world better. So,
yeah. So basically sharing your knowledge to make life of many people better in a very broad sense. That's incredible. Yeah. Thank you, Vijay, again. I'm sure we'll have you again more than one time. So just book your calendar in the future. And at this point, let me acknowledge our sponsors again. This is the list. And especially the strategic partners, ARM, Edge-Impulse, Qualcomm, Sentient, and the platinum sponsors, DeepLight, Clickertech, Reality, AI, Renaissance, Sony, and the gold sponsors, Analog Devices, PhotoHub, Latent AI, Microsoft, NXP, and who is this?
Seed Studio.
Yeah, Seed Studio, yeah, at the top. SenseML, ST Microelectronics, Synaptics, SynSense, and there is a list of silver strategic partners. Thank you again, and we'll see you again in a month at the September edition of the Trailblazers. Thank you, Vijay. Right. Thank you, Chris.
Thank you so much.
Yeah, thank you.
All have a great one.